Dynamic hip screw, DHS. The basic technique is briefly outlined as follows. After fracture reduction and preliminary K-wire fixation, a guide pin is drilled into the femoral head and the length measured. Then the tunnel for the implant is reamed. When necessary, tapped. And the dynamic hip screw inserted. Finally, the barrel of the plate is placed over the screw shaft and fixed to the femur with self-tapping screws. The fracture can be compressed with the DHS compression screw intraoperatively if desired. On the model, we will demonstrate the proper use step by step. First, we reduce the fracture. Since soft tissues are absent in our exercise, we begin by fixing the fracture with a pointed reduction forceps. The fracture is provisionally fixed with K-wires. These must be placed superiorly in the head so as not to interfere with the later guide wire placement. We now estimate the neck shaft angle. For this exercise, we chose an angle of 135 degrees and select the appropriate angle guide. The spikes on the underside prevent the guide from slipping. The guide allows the introduction of a guide pin or a 2mm drill bit. The entry point of the guide pin is determined on the preoperative X-ray of the contralateral side and takes into consideration the anteversion of the femoral neck. To measure the anteversion of the femoral neck, we use the appropriate angle guide to place a direction wire anteriorly on the neck and hammer it into the head. The angle guide is now placed on the femoral shaft and a 2mm hole drilled in the lateral cortex. The drilling direction should be through the center of the femoral head and parallel to the anteversion K-wire. The 2.5mm threaded guide wire is placed in the small Jacobs chuck with a small air drill and the 135-degree guide. The pin is inserted through the head and neck parallel to the anterior pin. The position of the guide pin is now checked both in AP and in axial view. It must be adjusted until it's correct. The direction wire can now be removed. The direct measuring device is slid over the end of the guide pin. The measuring device shows the length of the portion of the guide pin which has been drilled into the bone. Here it is 120mm. That means that the distance from the lateral cortex to the joint surface in this case amounts to 120mm. The hole to be drilled should end 10mm from the joint, and thus should be only 110mm deep. The DHS triple reamer consists of 3 elements. The assemblage is shown. On the drill shaft is a millimeter scale. The desired drill depth of 110mm can be set and the sliding nut tightened. The setting of 110mm is checked in the tightened position. The front part of the triple reamer drills the hole for the lag screw. The middle portion drills a larger diameter hole for the barrel of the plate, and the back part countersinks the cortex for the connection between the plate and barrel. We introduce the triple reamer into the universal drill and place the reamer over the guide pin until it contacts the bone. The hole is then reamed to the 3rd stage of the triple reamer. The drill should be run at full speed throughout. The reamer is removed carefully. With the plastic bone, the drilling debris must be shaken out. Should the guide pin inadvertently become loose and fall out, it must be exactly repositioned, or the screw may not come to lie in the correct position in the femoral head. To obtain optimal centering of the pin, the centering sleeve is first placed into the drill hole, then a long screw is placed in reverse within the centering sleeve. The guide pin can then be replaced in this way into the exact center of the previously made tunnel. For hard cancellous bone as well as in our plastic bone, the thread must be tapped. The tap assembly consists of the centering sleeve, the tap, and the T-handle. The tap is connected to the T-handle, and the centering sleeve slid over it and locked. The tap is now placed over the guide pin, and the centering sleeve pushed firmly into the drill hole. The hole is then tapped up to 110 millimeters. The depth of the hole is shown by the markings on the tap. From the screw selection, a DHS lag screw of the length equal to the depth of the drill hole is chosen, in this case 110 millimeters. From the DHS plate selection, a 4-hole 135-degree plate is used, as well as the sleeve and the wrench. The flattened outer side of the DHS corresponds to the inner shape of the barrel. The DHS plate is then placed over the wrench. Taking care that the flange of the wrench and slot of the screw properly interdigitate, the coupling screw within the wrench is then screwed into the inner thread of the DHS lag screw and tightened. After securing the centering sleeve on the wrench, the assembly is placed over the guide wire and the screw inserted. As soon as the O mark of the screw assembly reaches the lateral cortex, the DHS screw is at the end of the drill hole. This means that the tip of the DHS screw is 10 millimeters from the joint. In osteoporotic bone, the screw can be carefully inserted up to 5 millimeters deeper. At the end of the procedure, the T-handle of the wrench must be aligned parallel to the longitudinal axis of the femoral shaft, so that the barrel of the plate will slide over the screw, the flat side on the screw and the corresponding barrel part being horizontal. After removing the centering sleeve, we slide the DHS plate onto the screw and impact it using hammer and impactor. The wrench acts as a guide for precise use of the impactor. Concomitantly, the fracture zone is similarly impacted. The DHS plate is temporarily held in place with the self-centering bone-holding forceps. Subsequently, the coupling screw is loosened and the wrench removed. Using the small drill, the guide pin is removed by turning in a counterclockwise direction. The 2 provisional K wires are likewise removed. The DHS plate is then attached to the shaft of the femur. The screw holes are drilled in a neutral position using the green drill guide, and after depth measurement, the 4.5 millimeter self-tapping screws inserted. The screws are inserted by machine and finally tightened by hand. The fracture can be compressed with the DHS compression screw intraoperatively if desired. This, however, is seldom necessary. With osteoporotic bone, the compression screw must be carefully used in order to avoid pulling out the DHS lag screw. After achieving compression, the compression screw should be removed. At the time of hardware removal, the plate screws are taken out first, followed by the DHS plate. For removal of the DHS lag screw, the wrench with the coupling screw is needed. The wrench is placed over the DHS screw and the coupling screw attached. The DHS lag screw can then be removed without difficulty.